In this video, we are going to practice graphing logarithmic functions such as this one. The main thing to remember is when you're graphing logarithms, it's easiest if you start with the y values, and I'm just going to begin with y values -2, -1, 0, 1, and 2. I can always use these values because I like to begin by graphing the parent function without the +2 and without the negative sign. So the parent function is y equals log base 4 of x. Now, I already have the y's. What I need are the x's. So I will rewrite this function in exponent form so that I can get the x's. Now, in exponent form, we start with the base. All right, so there's my equal sign. So the base is 4. So I'm going to go ahead and put 4. Now the x and the y change sides. So the x comes over here, the y comes to the right and becomes the exponent. Okay, so this is the exponent form. X equals x equals 4 to the y power. So that means x is going to equal 4 to the -2 power, 4 to the -1 power, 4 to the 0 power, 4 to the 1 power, and 4 squared. Well, 4 squared is 16, 4 to the 1 is 4, anything to the 0 power is 1. Now these will be the reciprocals of these. So if this is 4 and 16, this will be 1/4 and 1/16. Alright, of course it does make sense directly. 4 to the -1 power, that -1 has the effect of dropping the 4 down to the denominator. And 4 to the -2 power is the same thing as 1 over 4 squared, which is 1 over 16. Now, I still haven't done the -1 in the front yet. Now, this is called an A value. All right, the number in the front is usually called A. And whenever there's an A value, we make a third column right here next to the y's. And what the third column is for is we take the A value, in this case -1, and we multiply by the y values and make a new y column. So if I multiply by -1, all it's going to do is change the signs. Alright, so now I've done the -1. That's going to be a reflection over the x-axis, and we've done that now. Alright, I'm not going to do my horizontal shift. Alright, we know this is going to be shift left 2, but let's save that for the end. So let's go ahead and plot these points. So x is 1/16, y is 2. So that means over to the right 1/16 and up 2. So 1/16 is so small you won't even see it happen. So I'm just going to go up 2. Alright, now I'm going to go right 1/4 and up 1. So that would be like 1/2. So 1/4 is just about there. Now I'm going to go right 1 up 0. One of my points disappeared. Okay, now I'm going to go right 4 down 1. And now I will go right 16 down 2. Alright. Right 16 is about here. It's off the grid, but that's okay. So these 5 points represent my function, except for I haven't done the shift left 2. This is always the opposite of the way it looks. So if it's positive, that will be left. If this were negative, I would go to the right. If there had been a number out here, it would have been an up-down number. Positive up and negative would be down. So do not connect these points because they are not the final answer. So if I take each of these and move them left 2, that will put me here. and here, and here, and here, and here. Alright, so these 5 points represent where my actual graph will be. Now, logarithmic functions have a vertical asymptote. The vertical asymptote started out as the y-axis. But since we shifted the entire graph left 2, then that means I will have a new vertical asymptote over here. You should draw the vertical asymptote as a dashed line. Okay, so our graph should approach the asymptote and never touch it. Now, when we draw it, it's going to appear to trace the line because it's going to be so close that you won't be able to see the difference. But in your mind, just understand that it never really ever reaches the asymptote. So your final graph should look something very much like this. Alright, let's do one more. Okay, let's take a look at number 15 here. And again, let us begin with the y values. And I will use the same y values as always. -2, -1, 0, 1, and 2. And again, I will start with the parent function. So I'm going to ignore the -4, the 2, and the 2 that's in the front. So if I do that, then what I'm starting out with, let's put it up here for a moment. What I'm starting out with is y equals log base 1/3 of x. Okay, that's my parent function. Now, I need the x's, so I can get that if I rewrite this in exponent form. I always start with the base, so my base is 1/3. Now the x and the y will change sides of the equation. So the x is going to come over here, and the y is going to come over here and become the exponent. So this is the exponent form of this equation. So now I can get the x values by doing 1/3 to the y power. So that means I'm going to do 1/3 to the -2 power, 1/3 to the -1 power, 1/3 to the 0 power, 1/3 to the 1 power, and 1/3 squared. Now 1/3 squared is just 1/9. I'm squaring the 1 and I'm squaring the 3. 1/3 to the 1 power is just 1/3. Anything to the 0 power is 1. Now these two will be the reciprocals of these two. So this will be 3 and this will be 9. Now if you want to understand why it's 9 more directly, if I have 1/3 to the -2 power, a fraction to a negative power, you take the reciprocal and make it a positive power. So this would be the same thing as 3 squared, which is 9. And again, if I have 1/3 to the -1 power, when you have a negative power, you do the reciprocal and make it positive. So the reciprocal of 1/3 is 3, and 3 to the 1 power, positive 1 power, is just 3. Okay, now we have an a value of 2. Anytime you have an a value, you're going to go ahead and make a third column next to the y's. Alright, and that third column will be the a value times the y value, so 2y in this case. If I multiply all these by 2, then I will have -4, -2, 0, 2, and 4. So we can dispense with the old y values since we've got these new y values. I'm not going to do the -4 or the 2 until the end. I'll do that transformation on the graph itself. So let's go ahead and graph this so far. Okay, so 9, -4. So I'm going to go over 9 and down to -4. All right, I've got 3, -2. I've got 1 comma 0, so over 1 up nothing. And then 1/3 comma 2, so that's over a tiny bit and up 2. And then I've got 1/9 comma 4. 1/9 is so small that it's going to appear to be right on the line. So these 5 points show me what the graph is doing. Okay, so I will, now it's time to go ahead and do the transformation of the -4 and the 2. So we know that the -4 is going to have the effect of moving the graph to the right by 4. Okay, and this +2 is going to move the graph up 2. So I'm going to take all 4 of these points and move them right 4 up 2. Okay. Alright, so there's right 4 up 2. Right 4 up 2. Okay, so these are the same 5 points moved right 4 and up 2. Now remember, the original graph had a vertical asymptote at the y-axis. That vertical asymptote will now be moved to the right 4. So now it will be here at x equals 4. Alright, you should always show the asymptote as a dotted line, such as this. So make sure you do that. Now, we can go ahead and draw the graph approaching the asymptote. And keep in mind that in reality, the graph should never touch the asymptote, but it's going to be so close here that it's going to appear to trace on the end. So your final graph should look something like this.